In this lesson, we are moving to one of the most important and powerful topics in C, which are pointers. Pointers allow us to directly work with memory, making C both powerful and flexible. So let us now dive in. So a pointer is a variable that stores the memory address of another variable. Okay, instead of storing a direct value like 10 or the pi value, which is 3.14, a pointer stores where that variable is located in memory. Think of a pointer as a map or a GPS location. It does not hold the treasure itself, but tells you where to find it. Okay, so let us now take a look at how we can declare a pointer. So the syntax for declaring a pointer is like this. Okay, so we need to provide the data type of the value stored in that memory. Okay, for example, integers. Okay, for example, integers for integers. Okay, so and another one, we should provide the pointer name. Okay, the pointer name. But this pointer name, it is prefixed, it is concatenated with the asterisk symbol like this. Okay, you can put it there like that, or you can put it here like that. Okay, like that. Okay, but the best way is to put it there. Okay, so this is the pointer name. Okay, so let me show you an example. Okay, let me show you an example. So let us see how we can assign addresses to pointers. Okay, how we can use them. Okay, by assigning addresses to pointers. Okay, so we use the address of operator, which is the ampersand, to store a variable's address in a pointer. Okay, so let us create a pointer. So for instance, if we have a pointer here, the pointer is going to be, let us name it pointer. The pointer, we are going to give it a certain value, but let us just make it to be like that. Okay, so here we are going to have a variable age, and remember this age, the value of age is going to be stored in memory. Okay, so we are going to create a pointer to age. Okay, this pointer is going to store the address of the age. Okay, and to get the address of the age, we use the ampersand sign and then the name of the age. Okay, like that, name of the variable, which is age. Okay, and this one is going to store the address of the age in pointer ptr, in this ptr. Okay, in this variable. Okay, which is a pointer. Okay, so from there, let us try to access the values. Okay, so let us use the printf. Okay, so in order to access, let us try to access the address of age, address of age, like that. So here we use ampersand p. Okay, ampersand p, which is like the format specifier for addresses. Okay, so from there, we're going to use ampersand age like that. Let us try to compare that value with another one. Okay, with the one in the ptr. Okay, so in order to use ptr, we don't need to use that ampersand because the address is already there. Okay, it is already there, but it remains an address. Okay, it remains an address. So we just get the ptr. We just get the value in ptr. So if we save and then we compile, and then we try to run, as you can see. But here, let us move the cursor to the next line so that we don't get confused. So if we try to run, compile and run, as you can see, they are the same. Okay, the value in age is the same. The address of age is the same as the value in the ptr, because the ptr just contain the address. Okay, just stores that address. Okay, it means they are the same. Okay, they are the same. The address of age is the same as that one of ptr. Okay, the value in ptr. Okay, so the pointer ptr holds the same address as the ampersand age. Okay, so let us now take a look at dereferencing a pointer. Okay, so if we want to access the value stored at the address a pointer points to, we use the dereference operator, which is the asterisk. Okay, so let us now take a look at how we can use it. So here we create a pointer which stores the address, to num, to age. Okay, so from there we come here. So in order to access this value, we can use the age, the value in age. We can just use the age. Then don't forget to change here. We need to change the format specifier. So the format specifier is going to be to integer. Okay, so from there, even this one we need to change to integer. Okay, like that. Then here, in order to access that value there, we use the dereference operator, which is asterisk. Okay, before the ptr. Okay, after that we save and then we try to compile, and then we run. As you can see, we get the value, okay, which is 25. Okay, we get that value like that. Okay, so the asterisk PTR gives the value stored at the address inside the P. Okay, at the address inside the P. Okay, so inside the PTR. Okay, so let us now take a look at how we can change our values via pointers. So you can even modify a value using a pointer by just following this step, okay, that I'm going to show you. Okay, so for instance, if we have our age set to 25 and we have our pointer to age, we can come right here, and then we can come here. So before, so this one is going to be like before like that. Then from there, this is going to be after changing. So let us come here. So after changing, let us come here, and then we try. So let us get that value using the PTR, using the dereference operator, and then we set it. Let us set it to be 20 like that. So after setting it to be 20, let us now try to print the value, okay, using this one, the value of age. Let us copy, and then we paste it there, okay, the value of age. So if we save, then we run, then we compile and run, as you can see, we get 20 here. Okay, so after changing, as you can see, we get 20. Okay, output, that will be the output. Okay, so modifying the asterisk PTR changes the actual variable, okay, variable which is age. Okay, so let us now take a look at pointers and arrays. In C, the name of an array is itself a pointer to its first element. Okay, so let us take a look at that. So for instance, let us remove all of this code, and we start working with array. So let us create an array of integers. So they are going to be, the maximum is going to be 3, and then let us set them to be, we have 10, let us have 20, and let us have 30 there, like that. So from there, we are going to start printing. Let me show you. Let us use the printf function. Then we are going to get the address of array. Let us get the address of array number 0, okay, at index 0. Let us get it. So we are going to get it at, it is going to be like this. So because it is a address, we are going to use the %p, then let us don't forget to break like that. Then from there, we are going to provide our array, okay. So we are going to provide our array like that. Then from there, let us try to copy all of this code here, like that, and then we paste it here. Then here, instead of here, we are going to get the address of PTR, okay, using this way, okay. We are going to get the 0 like that. Then we are going to use the ampersand to get the address like that, okay, like that. So after doing that, we are going to also do another thing. We are going to print the first element, okay, using a pointer, okay. So let us print the first element. So the first element using a pointer. So the first element is going to be like this. So here the first element is an integer like that, okay. So we are going to just remember I told you that in C, an array itself is okay, is a pointer to its first element, okay. So let me show you here. So here we use, so in order to get like the address, okay, in order to get the value, okay, at that address, we use the reference operator, and then we use array, our array name, okay. So from there, we are going to compile our code. Okay, after compiling, let us wait. We are going to run. So as you can see, so here, as you can see, we use the array. As you can see here, this is the actual way. Okay, so this one, if we use the array and just print it, okay, we just print it, we are going to get the memory address, okay, of that one. Okay, then here we try to access the first element, okay, the first element, but we want to get the address of the first element. As you can see, they are the same, okay, because an array contains the first element. An array itself is the memory address, okay, to its first element, okay. as you can see here. So if we try to print the value at that first element, at the address, okay, we try to dereference this address, okay, this address using the asterisk symbol. We are going to get the value which is 10. As you can see here, it is 10. Okay, so that is it. That is it. Let us now take a look at pointer arithmetic. You can move a pointer to access different elements in an array. Okay, so for instance, we can come down here. Let us delete all of this code, and we can come here and then we can use. So for instance, here we can come. So here we have our array, which is that one contains 3 elements. Then here we can come here and then we create a pointer. Let us name it P, and it is going to be pointing to what? To an array. Okay, to an array, to an array. Then from there we are going to start printing. This is going to contain the address, okay, of this array, okay, first element of the array. So we are going to use to do something. So here use the ampersand. So here we are going to get, so let us break the line. Then from there we are going to we're going to use the asterisk P, and this one is going to return us the first element. Okay, we are dereferencing. Okay, so it is going to return us the first element. Remember this one, okay, contains the memory location to its first element. Okay, so we are going to get 10 out. Then from there we are going to come here and then we do the same. Let me copy this line of code, paste it there. So here what are we going to do? Let us do something. So here we want to access the second element. Okay, so but in order to access the second element, we need to add, like, remember these are integers, okay, and 4 bytes are allocated to each of them. So which means the next element is 4 bytes, okay, more than the first one. Okay, so let us just get the first element, the address of the first element, and then we try to add. Let's add 1, okay, which is like 1 byte, okay, which is 4 bytes, okay, which is 4 bytes. Then from there, if we add a 1, okay, it is going to increment by 1, okay. So it's going to increment, like for instance, if we had the index of 0 and then we add a 1, we are going to get a 1, okay, which means this one is going to be 1, okay. It is going to point us to the second element. Then from there we are going to, and here we use the dereference operator to dereference that location. Okay, so from there we can do it onto with the next one. Let me copy. So with the next one, this one is going to be the third one. Okay, like that. So if we save, we're going to see that we are going to get the values out. Okay, all the elements. Okay, as you can see. So here we get this one. Okay, here we get this one. Here we get this one. So we are accessing a value out of bound. So we need to get 2. Use 2. So if we do that and we try to run, as you can see, we get 10, 20, and 30. Okay, we get those values out. Okay, like that. Okay, let us now take a look at pointers and strings. Okay, so before I go to pointers, let me just make this one. Let me briefly explain what we did, okay, previously. So adding 1 to a pointer moves it to the next element of the same type. Okay, just know that. So pointers, so a string in C is just a character array. Okay, so we can use pointers with strings. Okay, so let me show you something here. Let us try to remove all this code, all that code there, and even this array. So let us create a char, then here string, like that. Then this one is going to be hello, like that. So we have our character, our string there, it is hello. Then we are going to create a pointer to character. A pointer is going to, it is going to point to a character value. So ptr, a pointer, and it's going to be string. Remember these ones, okay? A pointer, okay, must be of the same type, data type as the value, okay, as the variable it is pointing to. Okay, so here we do that. If we do that, we can come here and then we set while. Let us use a while loop. So while asterisk p ptr asterisk ptr is not equals. Let's use is not equals to remember we have the null terminator. okay, at the end of the string. Okay, if it is not equals to this to null terminator, that one null terminator, then what are we going to do? Then we are going to use the printf function. Okay, we're going to use the printf function and we print out that character. Okay, if it is not like that. So let us add a space, then let us use let us dereference our pointer. Then from there, let us come here and then we increment. Okay, so let us increment our pointer address. Let us increment it like that. So after doing that, let us save and we see the output that we are going to get. Oh no, if ptr, as you can see, ptr, if asterisk ptr is not equals, so let me put something here. Let me use the ampersand here. Save. Oh, Control C. Oh, we get some errors. We get some errors, guys. We get some errors. So if ptr is not equals to this string here, this one here. So here we must use single quotes. Let us use single quotes, guys. Let's use single quotes there. And because it is a character, so if we compile and then we run, as you can see, we get hello like this. Okay, we get hello like that. Okay, so let us now take a look at null pointers. A pointer that does not point to anything should be assigned null. Okay, which it does not point to anything, it should be assigned null. So let us let me comment out all of this code, then come here. So here let us create a pointer that does not point to anything, ptr, then let us make it to be a null like that. So after doing that, let us now check. Okay, so if let us use the if statements. If ptr equals to null, what are we going to do? If it is equals to null, then we are going to use print pointer is null. Okay, so the pointer is null. Okay, like that. So a pointer which does not point to anything, you should set it to null like that. So as you can see, if we do that, as you can see, we get pointer is null. Okay, like that. Okay, so let us now take a look at pointer to pointer, which is called a double pointer. Okay, so a pointer can also store the address of another pointer. Okay, so let me show you an example here. Let me show you an example. Let me comment out all of this whole line of code. Go down here. So let us create an integer. Let us create an integer, and this one is going to be a number. It's going to be a number, and then let us set it to be 5 like that. Then from there, we create a pointer, another pointer. It's going to be, we create a pointer, okay? A pointer to the num address, okay? To the num. So ampersand, we use ampersand num. Then from there, we can come here and we create an int. Then it is going to be a pointer. Here we are going to create a double pointer. Okay. So instead of using a single one, we are going to use double. Okay. Double asterisk. Then it is going to be a pointer to a pointer. Okay. So we are pointing to the what? To the address. We're pointing to the address of ptr, to the ampersand of ptr, ampersand of p. Then from there, we are going to, let us try to print the value of the num. Okay. So if we try to print the value, so here we are printing value of num like that, value of num. Then here we are using ampersand d because it is an integer. Then let us break. Then from there, let us get the num like that. Okay. So let me copy all of this code, paste all of it there. So this one, in the next slide, we are going to print the value. Okay, using a single pointer. Okay. So because we are using pointer, it's going to remain the value. Okay, we are printing a string. So this one, the value using a single point. Okay, single point like that, a single pointer like that, and we are going to be using the asterisk p. Okay, asterisk p like that. Okay, by dereferencing. Okay, you know that. So let us now to print the value. Okay, using a double pointer. So we print, instead of, I don't want to repeat all of this code. Let me copy everything and I paste everything there. So here we are printing the value using a double pointer. A double pointer. So here instead of using single, we are using double, then pp, like that. So if we save and then we try to compile, then we run, as you can see, we get the values like that. Okay, we get the values like that.